Hello friends and welcome to another lecture. We had been discussing about the continuities in the last lecture, and I described what do you mean by a continuity or a discontinuity in the last lecture. Then we saw what do you mean by continuity at a point and at an interval. Now when a function is not continuous, it's called a discontinuous function. And the condition for continuity, as we all know, is that left hand limit should be equal to right hand limit, and that should be equal to function's value at that point in order to say that the function is continuous at that point. But there could be ways by which this condition doesn't satisfy. Like you can have left hand limit which is not equal to right hand limit. You can have left hand limit equal to right hand limit but not equal to the function's value at that point. And depending upon these kind of scenarios, you can have multiple types of discontinuities. So you can have removable discontinuity or you can have an essential discontinuity. Removable का मतलब a discontinuity which can be removed. The function can be made as a continuous function. But essential discontinuity means that the continuity cannot be removed. And there are two types of essential discontinuity. One is jump and another is infinite. So let's have a look at the removable discontinuity. Just have a look at this particular graph. You can see at this particular point, यहाँ पे x की जो भी वैल्यू हो उस particular point के ऊपर जो ग्राफ है वो मिसिंग है. Either the value of the function is not defined or it is infinite or it could be some other value, but it's just a point. एक पर्टिकुलर पॉइंट के ऊपर फंक्शन की जो वैल्यू है दैट इज मिसिंग और इट्स इनफाइनाइट. सो इस टाइप की डिसकॉन्टिन्यूटी को हम लोग रिमूवेबल डिसकॉन्टिन्यूटी कहते हैं. इफ यू हैव अ लुक एट दिस फंक्शन एफ ऑफ एक्स, यू सी दैट इट्स एक्स क्यूब माइनस एक्स स्क्वायर बाई एक्स माइनस वन. सो इसकी जो डोमेन है दैट डोमेन इज ऑफ ऑल रियल वैल्यूज बट एट वन the function is not defined क्योंकि this function goes at infinity at 1. So if I factorize the numerator, so अगर x minus 1 के अलावा मैं बाकी सब वैल्यूज़ के ऊपर इस फंक्शन को देखूँ तो I can cancel the numerators x minus 1 by denominators x minus 1 and I'll be left with x square. So I can say that this function is x square for all the values except at x is equal to 1 where it is not defined. And if I try to plot this function, this is how the function will look like. So this function is a parabola at all the values except at x is equal to 1 where the function's value is not defined. So यहाँ पे एक देख सकते हैं आप x is equal to 1 पे एक होल है और उसके अलावा ये function जो है ये एक parabola है. So this type of discontinuity where you find a hole is called a removable discontinuity. And if you're not given the graph, how will you identify whether the function has removable discontinuity? So if your left hand limit is equal to the right hand limit but your function's value at that particular point where you are checking the discontinuity or continuity is not equal to that limit, then we say that it has a removable discontinuity. And it is seen by the graph also. You can see कि इस पर्टिकुलर पॉइंट के ऊपर x इज इक्वल टू 1 पे वैल्यू डिफाइन नहीं है बट इसके लेफ्ट हैंड के ऊपर और राइट हैंड के ऊपर जो वैल्यूज़ है जो लिमिट की वैल्यू होगी दैट विल बी सेम बिकॉज इट्स अप्रोचिंग द सेम वैल्यू फ्रॉम बोथ द साइड्स. सो द लेफ्ट हैंड लिमिट इज इक्वल टू राइट हैंड लिमिट बट फंक्शंस वैल्यू at that point is either not defined or it is not equal to the limit. And if something like this happens, we say that it has a removable discontinuity at x is equal to a. So हम अपने function के अंदर भी देखें जो मैंने example लिया था. So if you check the limit at 1 minus यानी कि left hand limit, so we can factorize this and x minus 1 will get cancelled by x minus 1. You will be left with 1. The right hand limit also will give you the same value 1, but the function's value at x is equal to 1 is not defined. So since the left hand limit is equal to the right hand limit but not equal to the function's value at that point, we say that the function has a removable discontinuity. Now, if the function has a removable discontinuity, there has to be a way by which you can remove the discontinuity of this type, and that is what we will discuss here. So, अगर ये आपका ग्राफ है और यहाँ पे एक होल था, so what could be the way to remove the discontinuity? Fill this particular hole. इस particular hole के ऊपर अगर मैं कोई वैल्यू डाल दूँ जो वैल्यू इस कर्व को स्मूथ कर दे, then I have removed the discontinuity. And what will be that value? That value will be nothing but the limits value at that particular point. हम x is equal to 1 पे तो वैल्यू फाइंड नहीं कर सकते, but we can certainly find out the limits value at extending to 1. और उस वैल्यू से if I fill this particular hole, then I have removed the discontinuity. So I will make the function a piecewise function which will be x cube minus x square by x minus 1 for all values of x except at x is equal to 1. And for x is equal to 1, this will be the limit extending to 1 for function f of x, which in our case will be limit extending to 1 x square. यहाँ पे जब इसको फैक्टराइज करेंगे so x minus 1 का न्यूमरेटर से डिनोमिनेटर में कैंसिल हो जाएगा and you will be left with 1. And if you replace that 1 here with the limits value, then you have made the function a continuous one. Then you have the essential discontinuities. First is the jump type, and you have an infinite type of essential discontinuity which cannot be removed. So ये ग्राफ देखिए, this is an example of jump type of discontinuity, and it is very evident why it is called a jump type of discontinuity. ये ग्राफ बहुत स्मूथ है at some x naught की वैल्यू तक, and then suddenly it's taking a jump or a leap and it starts again. This is the function जिसका ये ग्राफ है. So x square is the function's value till x is approaching 1, and as soon as 1 is approached, then onwards it's a straight line x plus 1. So this is a discontinuity, and this type of discontinuity is called jump type discontinuity. And if your left hand limit or right hand limit, or perhaps I should say the limit at a particular point is taking infinite as the value, then you say that the type of discontinuity is essential discontinuity. We'll have a look at this in detail. So let's see the jump discontinuity first, and the identification for this is that your left hand limit should not be equal to your right hand limit, and both left hand limit and right hand limit should have a finite value. उस पॉइंट के ऊपर फंक्शन की क्या वैल्यू होगी दैट डज नॉट रियली मैटर, क्योंकि सिर्फ इतना ही अगर हमारा सेटिस्फाई हो जाता है तो वी कैन से दैट इट हैज़ अ डिसकंटिन्यूटी and it will be a jump discontinuity. If we look at the function that we discussed earlier, then its left hand limit is equal to 1 but the right hand limit is equal to 2. So since these two are not equal, so we can say that this has a jump discontinuity here at x is equal to 1. Well, if you see the infinite discontinuity, your left hand limit and right hand limit should have an infinite value. They both can be infinite on the positive side of y-axis or on the negative side, or one could be positive, another could be negative infinity, but they both have to go to infinite values. If we look at the example f of x equal 1 by x, then x की negative values के लिए this f of x will be negative, and as x reaches 0 from the left hand side, यानी कि negative side से, so the value of f of x will go to a very high value, a very infinite value, but a negative infinite value. And similarly, if it is approached by right hand side, then x will be positive. So जब x की value बहुत छोटी होगी, then f of x will be a huge value, an infinite value, but a positive infinite value. On the other hand, if you have a look at the 1 upon x square function, it does not matter you reach x equals 0 from left side or the right side, it's still gonna reach plus infinity, but again we would say that it has an infinite discontinuity. So these were the various types of discontinuities. Thank you so much.